Max, chillax.
Alright, so today we're going to go over some coding problems, okay? So these are very common problems. These are problems I've had in the past. And as you'll see, there's like a lot of solutions to the same problems. And if you haven't noticed that already. So let's go ahead and look at our first problem. Our objective is to swap values of 1 and 0. Say an event occurs in your patch, and when it's finished, it outputs a value like a 1, for example, and you need that data. You need that data that says this thing has finished. But instead of a 1, you want a 0. And maybe it outputs a 0. And when it outputs a 0, you want a 1. So all we got to do is flip the sign, right? Mm-hmm. So there are, again, many ways to do this. Let's look at the first possibility I have here. Select is kind of like selective listening. So say you're, hanging out at a family thing, and they're all talking about chemistry or something that a discipline you're not interested in at all. And then for whatever reason, you hear them drop the name Stockhausen. You're like, hmm? I could contribute to this conversation now. So it's like selective listening. The computer's doing the same thing. It's only looking for the things that it's interested in, right? Or that it knows about. In this case, I have just a 0 and a 1. So it's going to listen for just zeros and ones. And when it gets a 0, it's going to output a bang. And in this case, it's going to hit a 1, right? So when we get a 0, it's going to hit a 1, and it's going to send a 1 out, right? And then the opposite is true. When it gets a 1, it sends a bang out the second outlet, hits a 0, and then gives us what we want, a 0 instead of a 1. And it works just fine. I gave it a 1, it output a 0. I give it a 0, it outputs a 1. Cool? Cool. So I see this one all the time, but there are better ways to do this. First of all, it took 3 objects to get that going, right? To get that logic through. Jordan?
To be clear, are we just doing 0 and 1 or everything in between?
For now, just 0 and 1.
Okay.
Yeah. We just want to flip the sign. This is a very common problem. I have to do it like 10 times per patch, it seems like, if the patch is substantially large or something. Okay, so yeah, we have 3 objects. We could try to figure out a way to condense it down to less, because usually less is better. So we could do an if-then statement. So if $I1, which basically is saying the integer variable coming in the first inlet, okay, if that equals 0, then 1. Else, or otherwise, 0. Cool? So, and it works just the same as select 0, 1. If the integer variable in the first outlet equals 0, then 1. Does it equal 0? No. So, else, 0. And then it's shot out to 0. Cool. And
Why do you need 2 equal
Those
signs?
little things are, how do you create just the little switches?
Oh, those are toggles.
Toggles.
So,
Okay, there we go.
and the quick key is T.
Yeah.
Exactly.
Why do you need 2 equal signs? Just part of the logic?
Yeah, it's common in most programming languages to have 2 equals. So,
Alright.
yeah.
So it will not work if you have 1.
Correct. If I did this, let's see. Well, did that? All of a sudden it's pink, and my message box is going to say, nope, equals bad expression.
Okay.
Cool. So let's just undo that. And so yes, it works just fine. Cool. But there are other ways to do it. let's look at the next one. We can use math. Okay, so let's think about this. You give it a 1. First, you subtract the 1 from the 1, which gives you what? 0, yes, this is easy.
Okay.
Not a trick question. And then you take the absolute value of 0, which is 0. And that gives you a 0.
Just as
And if you give it a 0, you subtract 1, which is
negative
-1. Take the absolute value of -1.
1.
1. Cool. And you don't even have to use absolute value. You can just use times -1, right? Because 0 times -1 is
Negative
0.
0.
-0.
There we go.
And then -1 times -1,
1.
1. Cool. So yes, you can use math. In this case, it's not really making it any sleeker than our if-then statement, right? It's a little more clunky, if you will. And then we have the best solution. It's not always the right solution, and I'll show you why soon. But this one is probably the sleekest, most elegant, most efficient way. Boolean operators. Equal 0.
Wow.
That's all you need, and it'll swap your sign. How? Have you guys run across Boolean, that term, ever?
Yeah. It's like and or.
True, false is the most. It's basically you're asking the computer a yes or no question. Okay, does it equal 0? And the computer answers the question in a form of a 1 and 0 rather than yes and no, respectively. So, does it equal 0? Right now, yes. So, instead of yes, they say 1. I still said they. The computer. The computer says 1. And then vice versa. Does it equal 0? No. So, no is 0. Cool. So now we're presented with a new question. What happens if you give these values what happens if you give all these objects values other than 1 or 0? Because oftentimes, sometimes you're not just dealing with data 1s and 0s. Sometimes you're getting, 8001, 8002, 8003, 0. Stockhausen, 1. Boom. You see what I'm saying? It's just, you got data streams and there's a ton of it. And sometimes you just want to only listen to 0s and 1s. In that case, select 0, 1 is sometimes the best version. Because let's look at what we got here. This works perfectly with 0s and 1s, right? But once we give it a 3, 4, 5, 6, all of a sudden the math is giving us what looks like 1s, and the rest are not giving us anything. If we go down to the negative domain, we got math going on, giving us 1s. The Boolean and the if-then is giving us 0s. And the select is giving us a 1. Why is the select giving us a 1?
It's not 0.
Because that was the last thing you gave it?
Yeah,
okay.
because when I was scrolling down, I hit the 1. I was, say I started at 4. 4 didn't notice anything. 3 didn't notice anything. 2 didn't care. 1, okay, that means 0, right? And then I gave it a 0, and then it said -1, right? And then when I gave it a 2, I got lost there. When I gave it a 0, it output a 1, and then when I continued scrolling to the -1, nothing happened. It was left on, right? So, yeah.
So if this was playing like a sine tone, it would just keep playing that sine tone.
It wouldn't, because we're dealing with control rate data right now.
Okay.
But I think there's a situation in the MSP environment where that could happen, but it would be kind of like DC or something. Yeah. It would get stuck.
Yeah.
Unless it got a 0 or 1 or whatever.
So basically what's happening is if it's 0, then yes. If it's not 0, then no. Like your if, then else thing.
Exactly.
Okay.
Exactly. But in this case, anything other than 0 is going to always output a 0.
Mm-hmm.
So if I give this a -1000, whoa, not dashes, 1000, it's going to generate a 0 because it's otherwise, it's not 0, right? Whereas this is still left on from when I hit a 0 earlier. Cool?
Right.
All right. So we're good with this stuff. So basically, the moral of the story is you got to kind of know what type of data you have before you make the decision. Typically, this is going to be your most efficient method right here. But if you're getting data other than 1s and 0s, it might affect the outcome, right? Cool? All right. I'll post these all on my website, so you don't necessarily have to copy it down. Position matters. Okay. Whoa, 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 whoa. I don't wanna... Let me get this out. Oh, let's make this smaller. Sorry. Okay. Let's clear this. So, we cool with what the print object does? It basically, I showed you before, I gave you an argument of 1, 2, and 3, so that way we know which print is printing.
Yeah.
Okay, so it'll show up in the object of which print it is, and then it'll display the values that it received. So I'm going to hit bang. What's going to happen? Good.
You already know the answer.
Yeah, if you don't already know the answer, what would you have assumed?
Left to right.
Left to right. So it would have gone print 1, print 2, print 3, and we would see, nope, 3, 2, 1.
Why does it do that?
I'll get to that in a second.
Because it's Arabic.
Yeah,
Good one.
it's just a different language. Yeah, you just got to kind of learn a new language. 1, 2, 3.
3, 2, 1.
Really?
Bottom to top.
3, 2, 1, because it reads from bottom to top. Top. Yeah, it's like completely the opposite
Yeah.
of what we do.
It's like Chinese.
Basically,
Oh, they didn't talk down, don't they?
Yeah.
so what happens if I move print 1 a pixel to the right and print 3 a pixel to the left?
Which?
2, 3, 1. 3, 1, 2. Nothing happens.
So the order of operations, you have to know the order of operations. So you know that even though this looks like it's most likely you would read it from bottom to top, actually it's the other way around. It's going from right to left, because right to left is the default, and if it sees a discrepancy, it reads bottom to top. So, yep, 1, 2, 3. And you probably can't see that at all, but there it is.
So why did it do 1, 2, 3 this time?
Right to left.
Because the
Okay,
order of
okay.
operations
Alright,
is
yeah,
it looks left or right to left,
And then bottom to top.
and then bottom to top. Now, there's a good answer for why right to left. And that's usually because our objects look something like this. It's a box, and usually in most of them you have an inlet here and an inlet here, right? And then you have, and you usually have more inlets or more outlets, but this is a very common form of an object, right? We've seen a bunch that look like this. Usually, whatever it is, you put the variable or message in first, right? And then you put something in here, and when it goes in the left inlet, that's what executes the operation, right? So, and have you seen this yet? Have you noticed that a lot of, you have to set this first, and then,
Like with the adding box?
yes, exactly, with adding.
The right one stores the number that you want, and then the left one.
Exactly. So you store the number in here, and then when you put the other number that you want to add into the left inlet, then the operation happens. So that's a good reason for the right to left logic, right? Because a lot of your objects accept data that way. Cool? Alright, so, and the bottom to top, I still can't wrap my head around that one. But just know that that's how it is. That's how it goes.
Like, I don't get, like, it says depth first too, depth in, what is that?
Depth.
Well, like, I know because, you know, the tutorial and all that.
Yeah.
But the third one was that there's 3 alterations. It's bottom to top, right to left, and then depth first, like traversial or something like that.
Depth. I'll have to look at that to see what they're talking about.
Yeah, because it's like, if you have one channel, and then it has like 3 other channels out of those, like the bottomest one goes first, and then one on the top.
Okay. I'll look at that. It's been a while since I've looked at those tutorial videos, but yeah. Let's just do one more quiz. I put it in order like this. But this one a pixel up, this one a pixel down.
It's still 3, 2, 1.
Still 3, 2, 1.
Yeah.
Good. Just making sure you're. What about now?
2, 1.
These are aligned. This is a pixel, well, at least a couple pixels up.
2, 1, 3.
It still reads right to left first, right?
Exactly.
Okay.
So yes, 2, 1, 3. Now this one, it's aligned.
2, 3, 1.
2, 3, 1.
Prove
Yeah,
it.
so
Prove it.
you'll get used to it. It's just, and as you'll see, most of the time you won't have to worry about it because you're going to hard patch the order if you need it, the order to be what you want it to be. Boom. T, B, B, B. Triggers are our friends. It keeps everything in order. Okay. Now, when I hit this, what's the order going to be?
It's going to be 1, 2, 3.
3, 2, 1.
Or 3, 2.
1, 2.
1, 2. I can't tell which B is which. They're all B's.
They're all B's. They're all the same B's.
So 1, 2, 3.
1, 2, 3 it is. Because it's reading this box
From right to left.
from right to left. It's okay. You just got to remember, switch everything you know, and you're cool. Okay?
Perfect.
Yeah. So it's always going to be 1, 2, 3. If I move this guy way over here, 1, 2, 3. See, 1, 2, 3. You can take my word for it too.
Oh, okay.
What did you move? Oh, that thing.
Yeah, I moved this up here. 1, 2, 3. Always 1, 2, 3. So let's put those back. Cool. So we're cool with that.
Don't really get how that object works.
So the T stands for trigger. So when it gets the bang, it's saying trigger, bang, bang, bang. Okay. And yes, it's quite the gun reference right there. And it's going to do this bang first, and then this bang, and then this bang. And you
These
could give,
correspond with that outlets.
yeah, they correspond with the outlets, exactly. So the third bang corresponds with the third outlet,
So if you
and that'll happen first because it reads right to left.
Okay. So if you had like 5 B's and then it'd be 5 outlets.
Exactly.
Okay.
You know, I could also do T, B, 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 L, I, F, hello. And let's look at that. Let's print. This is really messy, but my screen is really big. And well, it's not gonna, let's give it an int, or a float. Let's give it a 3.5 message. Come on. 3.5. Okay, what do we get? First one was a hello. Let's zoom in. First one was a hello. Second one was a float, right? And it output the 3.5. And then the third one was an int, so it output a 3. It truncated the 0.5, right? Then what happened in the third one? Oh, a list is just going, like if I had more than one things going into that inlet, like hello Jordan, both of those would have came through. Cool, so it came, hello Jordan 25. That would have all came through. Cool. And then my normal bang, bang, bang.
All
All right.
right. A band now called Hello Jordan 25.
That sounds like a good idea.
First album, Bang Bang Bang.
So does the Uzi object go by placement or what? Because you just tell it a number of things.
So the Uzi, what's that? It's Uzi is going to just spit out a ton of bangs, and it's I think the third outlet is like the index number and stuff.
Yeah.
So or I forget what the second one is off my head. I would just have to roll my. But anyways, yeah, it's different. It's used for other purposes, but it kind of has a similar nature to it, like because you trigger multiple bangs. Yeah, but that would be like doing this. Trigger, bang, 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 and then maybe in this message box, put them all in here, in the one place. Does that make sense?
Yeah.
So it's a little different. Cool.
Okay.
Next objective. Odds and sorry, Daniel.
For this max object, how fast are the bangs happening?
Like, pretty much as immediate as possible. Every whatever the control rate is, which is usually every 1,000.
So an MSP is going to be slightly slower, right?
It's essentially instantaneous for most of our purposes. But
Okay.
yeah, it is. I'm pretty sure it comes out every 1,000th of a second. Cool. All right. Our objective is to separate odds and evens, okay? So we want a string of logic that's going to, for now, we'll just say every time it receives a 1 or an odd number, it outputs a 1, and every time it receives an even number, it outputs a 0. Cool? Let's look at this way. This is the stupidest way possible, but it actually works. Oh, but not all the time. So right now it's a 0, so it's an even number, and there's a 0 down there. Let's give it a 1, 3, 4, 5, 6, see what I'm doing? And it's working. It's always reporting whether, see it already got off set. Yeah, now it's back on set. So we have 177 and it's displaying a 1. Cool? But what if I gave it a 1, 79. It's going to output an integer, and the bang is going to interpret that integer as just a bang, and then the bang is going to bang through, and it's going to toggle the toggle. And what's going to happen is it's going to toggle.
Should write that down.
I should. It's going to toggle, but since I skipped a number instead of gone consecutively, now it's offset. Now all my odds are evens. So if you have really just slow data coming in that you want to parse, whether it's odds and evens, and it's always consecutive, like it's either going up one or down one, then this method is going to work. But most of the time, you're not going to have that type of data. Most of the time, your data is going to be skipping around and doing crazy stuff. So this method is pretty bad. And not only that, is when you can use non-graphic objects. Okay? So this is doing the exact same thing. It's triggering a bang. But now the graphics doesn't have to, you know, blink every single time it does it, right? I mean, you still have the graphics going down with these toggle boxes, but it's just a little bit more efficient. Does that make sense?
So, like, the trigger bang about these send out a bang every time it changes?
Exactly. Every time it changes, it's just sending a bang, and the toggle is interpreting each bang as like a trigger to toggle. It's hard to use words that aren't also Max words to describe what it's doing. So does that make sense?
Yeah.
So, yeah. Okay. Next method. Math. And Boolean. What am I doing? I want you guys to figure out what I'm doing here.
Okay, so you're multiplying whatever the integer is coming in by half.
By 0.5.
Then
Yeah.
you have so it's a floating, it could be a floating point?
I have a trigger
A
Fi.
floating
If you can't see.
Floating and integer.
Floating and integer?
Yeah.
Okay, so those are both linked into the floating point.
What happens when a float receives something on the right and what?
So the integer is stored.
When
Or is that, no, that's not a float, that's an object, never mind, with a zero. A minus zero?
oh yeah, a minus 0.
Oh, minus 0.
Yeah.
So
Okay,
you're
okay, so it's
one.
going to subtract the float point to the integer.
It's going to subtract the integer from the float
That
point.
one, yeah.
Oh.
The other way around.
Oh.
And then,
Frenchie, you want to?
And if you're left with a 5, that means it had, like a 0.5, that means it is odd because it wasn't equally divided.
Boom.
Yay!
Yeah. So it's kind of a clever way. It's kind of a clever way to look at the remainder by first truncating the 0.5 off of any of the odd numbers that we would have gotten, right? By just calling this an I, right? Actually, I think I say it really well here. I should just read it here. Say it's a 7. Multiply it by 0.5 gives you 3.5. Calling a float a 3.5 will give you a 3.5. Calling an integer a 3.5 will give you a 3 because it truncates the 0.5 off. Subtracting well, if you do 3.5 minus 3, it'll equal 0.5. And the Boolean operator is, does it equal 0.5? And the answer is yes. And yes and no answers come in the form of 1 and 0.
Which comes in the form of X's and
Which, in this way, yeah, in the way that we're looking at it now, because toggle displays a 1 as an X, and then a 0 as an empty box. Now, just so we're all cool, let's replace 7 with 2, and you guys tell me how it works. Say it's a 2. Multiply it by 0.5.
You get a 1.
Calling it a float will give you a
1.
calling it an integer will give you a
1.
subtract 1 minus 1
0.
0. Boolean, does it equal 0.5?
No.
Yeah. Cool.
The connections are just from the
Yeah.
TFI into the minus 0.
Yeah.
Why?
What's going on here?
Yeah, it was exactly what's going on.
So, okay, let's look. Let's just zoom in way into this guy.
So that's just the subtraction problem, right?
Yeah, the subtraction occurs right here. But we need, before we subtract, we need the float and the integer, right?
Right.
So when I get my value, I'm basically separating the two by saying trigger the integer that you just got, which truncates everything off, and then trigger the float that you just got, which doesn't truncate, and then,
So you
but first, this is actually a perfect example of a right to left type of situation, because you store the integer here, which is in the case that it's an odd number, it's going to be smaller than our float, right? Because it knocked away the 0.5. So, and then when the float comes into here, it will, then that's when it executes the operation, the subtraction operation. Cool.
So
All right.
If you have a function, you space it out, like it's going to create another like area to connect from.
Say that one more time.
Always, like so, like the F and the I, they create like outputs. that
Yes,
can
when you give them those arguments,
arguments
they
as a term.
they will create those outlets
Okay.
depending on how many of those you have. Yeah. Now, there's a better way, super sleek way of doing this. One thing I've noticed is that usually finding the sleekest way to do this is usually a matter of knowing more objects, right? Because if I would have known this object, that's all I needed.
Oh, the modulo.
Exactly, modulo, or it reports the remainder. And it's basically doing the exact same thing that this is doing, only,
Not convoluted.
yes, right there. And you could give it whatever you want. In this case, we want binary numbers, right? We want our output, we want a 0 and a 1 for our toggle to display that way, right? And so we give it a binary argument, 2. And then that's going to do the same thing. Cool, huh? Now, what if you wanted a 0 for odds and a 1 for evens?
You combine the thing that we did at the beginning.
Yes, yes. Exactly, this is a perfect case where you would, you would need to swap the sign, like I talked about before. And it happens more times than you think. So our really sleek way was to, well, there's actually 2 really nice, sleek ways.
Just add one.
Add 1. I could do the, well, let's do the one we just learned, which was our Boolean operator equals 0. I'll give it a dot for now. I don't need a dot actually, but. And now it's flipped. So now my odd numbers are reporting 0s, and my even numbers are reporting 1s. So, cool. But what did you say, Ryan? Add 1. And same thing. Even numbers report 1s, odd numbers report zeros. Makes sense, right? Because we just, you could even do add 95 if you wanted to be,
As long as it's like an odd number.
as long as it's an odd number. Yeah. Excellent. Oops. All right, new objective. Convert milliseconds to BPM.
Ooh, I've already done this one.
Good. Yeah, it's a very common one that you will find yourself doing a lot, especially if you're making a GUI that performers will use, right? Because performers, if you say, oh, the tempo is 1025 millisecond delay times, that means nothing to them. It might start to mean something to you guys as you continue doing this stuff, right? Because you'll get used to it. But they're used to seeing metronomes, turning them onto the beats per minute that they need. That's written in the score, right? So, yeah, millisecond delay times mean nothing. I don't have to explain this to you. You probably hated the fact that we have to use millisecond delay times instead of beat per minute now, right? So, let's look at our clunky solution. So first, we have to divide 60 by the milliseconds in order to get our elapsed seconds. So that's a little confusing, right? You have to do 60 over the variable, right? And so what we have to do is we're setting the variable here, and then every time we do that, we also knock the top of the head of this message, which will shoot a 60 down into it, right? And then it'll do the division operation. And then we have to multiply by 1,000 to get the millisecond delay time, right? So yeah, and it works. If I give it a 1,000, what should it be? 60 beats per minute.
Yeah.
Because that's 1,000 milliseconds,
This is 1 second.
which is 1 second, which is, yes, exactly. You just went backwards to talk your way through that. And if I gave it 500, what it'll be?
After that, whatever that, or double that.
It'd be 120.
120, good. So it works. But what if I was editing, and for whatever reason, I moved this guy over here? Now what?
You shouldn't have done it.
You shouldn't have done it. That's one. Answer number one. What happens? Talk me through it. It reads from right to left, yes. So it would have hit the 60 first.
So that would be the stored number? Or?
So no, that would have done the operation before we
Oh.
set
Right. Yeah.
our variable.
Okay.
So now if I go back to 1,000, what's going to happen?
Isn't this still going to be 60?
It's 1,000 divided by 6.
It's going to be whatever the previous
Number was.
number one was, which was 500.
Oh, so still be double.
It's not going to move. It's going to be 120.
So if you change it again, it's going to be 60?
If I changed it to 1,000 again.
Well,
But
you
no,
just
if you
did
change it again now.
just now.
Yes, if I put in 1,000 again,
Or any.
then it's going to be, no. Yeah, I think so.
I just did it, didn't I? To 60?
But I put 1,000 in.
Put in like 20 and then put in 1,000.
Okay. 20. Still 60. Yeah. Yeah, exactly. It'll be like one off.
Yeah.
It'll be one delayed.
Cool.
and now it's 3,000 beats per minute. Because 20 millisecond delay times is pretty darn fast, right? Cool. So yeah, we can condense. First, we can fix that problem of potentially damaging our logic because we moved something over to the right. We could do that by using what?
Oh, trigger.
Triggers. And we can condense some of the math. The math is a little, I mean, why do 3 operations when we can do less, right? So here's this better one. So now TBF, so every time this changes, let me actually move this back real quick. Every time this changes, first it's going to throw the float down into here, so it's going to set our variable. Then it's going to bang the top of this 60,000. And what is 60,000? Where is that number coming from?
Because it's in
1,000
thousands.
milliseconds.
Times a
Oh wait, milliseconds are in 1,000.
Times 1,000
Times 60.
times 60. Because before I was basically doing 60 over x times 1,000, right? The numerator, you can put the numerators of those two multipliers to in the same one and just multiply them, right? So it's 60,000 over x.
Took me a long time to figure that out.
Yeah. So, and it works. Cool?
Cool.
And that's a lot better than what we had. But it gets better.
But wait, there's more.
Okay. So here's just one step closer to our perfect solution, right? It goes through the float, it sets our variable, and then I can put a number in my trigger. So I don't have to bang the top of a message anymore. I could just shoot a number down out of my trigger, right? And it works.
Yes.
Cool. All right. Gets better. One object. What? So expression. You can do a ton of math all in one object. Expression, and then 60,000 dot. I usually like to work with floats, sometimes unnecessarily so. Over $F1, and what does that mean?
You said F1?
The first input.
Float.
The
Variable.
float?
Variable?
Yes. So, yeah, those are the 3 keywords. Float, variable, first inlet, right? And actually, let's go back to here. I want to, where did I use that before? Yeah, over here. If I were to say if $I1 equals $I2, then 1, well, what happens? All of a sudden we have a new inlet so that you can throw your $I2s in there. Cool?
Cool.
So, all right, there's one more. Yeah, it gets even sleeker than this.
Possibly.
How is that possible? Boom.
Oh.
What?
And yes, this is, again, a matter of just knowing a boatload of objects, right? You have the exclamation mark, divide. What does that do? You can kind of figure it out, but just by looking at it.
Exclamation mark.
Whoa. Where
Is that the sum of everything?
why do I keep going there?
Is that the sum of everything?
It's dividing the input from the number that you gave it.
Well, why an exclamation mark?
Well, it's math.
That's a good question, yeah.
Because it's not like the math exclamation.
Right. The factorial you were thinking about, yeah. It's basically flipping the divide sign. Does Does that make sense?
Explanation.
So for a normal divide, when you put something in the left inlet, that something has to be the numerator, right?
Mhm.
And you have to set your denominator ahead of time. In this case, we want to have we want this thing to execute when we report the variable, which is the denominator. Denominator, there it is. And so we use the exclamation mark over 60,000 because 60,000 is always going to be our numerator, and our thing that's changing is our denominator.
Okay, so that exclamation mark indicates that it's flipped.
Exactly.
Okay.
And the same thing is true with minus signs. So if you want to subtract 1 from, or if you want to subtract something from 1 every time, then you can do a $sign, sorry, not $sign, exclamation mark minus 1, which is different than minus 1, because let's put our I here, and let's put our I here. Come on. Right? Can you see that?
Yeah.
Cool.
What happens if you go back down again? Just for fun?
Okay, that's cool. Yeah. These are very useful.
Yeah, but that one's really useful.
Yeah, that one's very useful. Divide, exclamation mark, divide is very useful too.
Would
I
that
use
not
it
be the
regularly.
same as multiplying it by like 0.0006 or no, that's not the same.
You would have to figure out the decimal version of. Yeah, it would. Yeah, 1 over exactly. So yeah, it would just be more math. And even though yes, dividing is not as computationally efficient as multiplying by a decimal, when you would have to figure out the decimal and then do the multiplication, that's more math. So.
Yeah, well,
And then divide anyways.
in this case, it would be one of those ones where it never ends, so it's easier to do that one.
Right. Cool. Now here's something crazy.
Dan, you should play like a really loud sound and wake you up.
Probably shouldn't.
It's really easy to. Just square.
All right. So what's going to happen if I give these a 0?
Divide by 0 errors.
Yes.
Probably.
Exactly. 0. Boom. We got 3 different things. If you look at here, these first 3, they're like the same. They're very similar-ish. Why are you? Let me just open. There we go. These first 3 give infinity, right? This one gives us a 60,000, which is just wrong.
Does it like automate into 1, I guess?
Exactly. It automates it to no. Yeah. It automates the variable to a 1.
Like,
Exactly.
Just can't handle it.
And then this one automates the variable to. Actually, how would you get a 0?
That'd have to be in the numerator of some sort.
Yeah, it automates the numerator to a 0 or something weird like that.
Yeah.
So chances are you're not going to come across a situation when you want like a metronome at 0, right, or infinity. So it's usually not going to be an issue, but you do have to kind of be aware of how these things interpret, how these different solutions interpret things like divide by 0 and stuff like that.
Computer explode.
Yeah, thankfully, that is not the case. There's some protection against that.
That's what used to happen with speakers, right? Or if you overloaded them, or whatever we're talking about.
Yeah, I don't know. Cool. All right, you're good to go. I will post this online, and you will study it because it's actually really useful information on this thing. Thanks. Cool.
Agreed.